There are worlds out there stranger than anything science fiction ever imagined. Planets made of diamond, planets raining glass sideways, planets that shouldn't exist at all. Let's go through every single type of exoplanet ever discovered. Hot Jupiters. These were the very first exoplanets scientists ever confirmed. Hot Jupiters are massive gas giants similar in size to our own Jupiter, but orbiting insanely close to their host star, sometimes closer than Mercury is to our Sun. That closeness bakes their outer atmosphere to temperatures over 1,000 degrees Celsius. Some hot Jupiters are so extreme, scientists believe it literally rains glass sideways due to violent near-supersonic winds. Super-Earths. This category doesn't exist in our own solar system at all. Super-Earths are rocky planets larger than Earth but smaller than Neptune. They're actually one of the most common planet types found across the galaxy, which is strange considering we don't have a single example close to home. Some super-Earths may have gravity strong enough that a person standing on the surface would weigh 2 or 3 times what they weigh here. Mini-Neptunes. Slightly bigger than super-Earths, Mini-Neptunes are thought to have thick hydrogen and helium atmospheres wrapped around a smaller rocky or icy core. They're incredibly common throughout the galaxy, yet scientists still aren't entirely sure where the line is between a large rocky super-Earth and a small gassy mini-Neptune. It's one of the biggest open questions in exoplanet science today: ocean worlds. Some exoplanets may be almost entirely covered in liquid water, with oceans potentially hundreds of kilometers deep, far deeper than anything on Earth. These are sometimes called Hycean worlds, combining the words hydrogen and ocean, because scientists believe they might have thick hydrogen atmospheres sitting directly above a global ocean surface. Lava worlds. Lava worlds orbit so close to their star that their day side is permanently molten. Picture a planet with an ocean, but instead of water, it's liquid rock. As that lava ocean evaporates under extreme heat, it can condense into rock clouds and rain molten droplets back down onto the surface. The temperature difference between the day side and night side can be over 1,000 degrees. Diamond planets. Under the right pressure and carbon-rich conditions, scientists believe some exoplanets could form with interiors made largely of crystallized carbon, essentially giant diamonds instead of rock. One candidate orbiting a pulsar is estimated to be several times the mass of Jupiter and potentially worth more than the entire global economy, if such a concept even applied to a planet nobody could ever reach. Rogue planets. Not every planet orbits a star. Rogue planets drift alone through interstellar space, either ejected from their original solar system by gravitational chaos or formed independently in the cold dark between stars. Scientists estimate there could be billions of rogue planets in our galaxy alone, some potentially Earth-sized, wandering forever in permanent darkness with no sun to warm them. Tidally locked planets. Many exoplanets, especially those orbiting small red dwarf stars, become tidally locked, meaning one side always faces the star while the other remains in permanent night. That creates an extreme divide, a blazing hot day side and a frozen sunless night side, possibly with a narrow habitable strip caught permanently in between called the Terminator Zone. Puffy planets. Some exoplanets have such low density they technically float in water if you somehow found an ocean big enough to test it. These puffy planets have thick extended atmospheres that make them appear enormous while containing surprisingly little mass. One famous example has roughly the density of styrofoam. Circumbinary planets. These are planets that orbit not one star but two, circling both stars as a combined pair from a distance. If you stood on the surface of a circumbinary planet, you could potentially watch 2 sunsets happen at once, each star setting at a slightly different point on the horizon. A real-life version of a famous science fiction double sunset scene. Eccentric Orbit planets. Most planets in our solar system move in nearly circular orbits. Some exoplanets don't. Their orbits are highly elongated, stretching them from extremely close to their star at one point in the orbit to extremely far away at another. That means a single year on that planet could swing between scorching heat and deep freeze over and over again. Habitable Zone planets. This is the category everyone hopes to find more of. Habitable zone planets orbit at just the right distance from their star for liquid water to potentially exist on the surface. Not too hot, not too cold. Scientists sometimes call this the Goldilocks zone. Finding a rocky planet in this zone is one of the strongest indicators that a world might be capable of supporting life. Failed planets. Some objects sit right on the boundary between planet and star. Brown dwarfs, sometimes loosely grouped with exoplanets, never gathered enough mass to trigger full nuclear fusion like a real star. They're too big to be ordinary planets, but too small and dim to be true stars. Cosmic in-betweens that never fully became what they might have been. Direct imaging planets. Most exoplanets are detected indirectly, through tiny dips in starlight or subtle gravitational wobbles. A rare few have actually been directly photographed. These are almost always massive young gas giants still glowing faintly from the heat of their own formation, far enough from their star that a telescope can separate the planet's faint light from the star's overwhelming glare. So what does all of this tell us? Out of the thousands of exoplanets confirmed so far, no two are exactly alike. Some are drowning in endless oceans. Some are boiling under molten skies. Some drift completely alone, with no star to call their own. And we've barely scratched the surface. Scientists estimate there could be more planets in our galaxy than there are stars, which means for every star you can see in the night sky, there may be several worlds hiding in the darkness beside it, each one stranger than the last. Somewhere out there, right now, a planet is raining glass. A planet is drifting alone in permanent night. A planet impossibly might be made of diamond, and we're only just beginning to find them.